So here's our little stub adapter that's going to go into the end of the shaft. This screws into the shaft, of course. Your drill stems attach right here. This is a tapered thread that all the stems have. So what we want to determine, we want to be sure that we're selecting the right pitch for this. And the way that I count this, I'm going to use my hook rule here and just catch the edge of the first thread, and then you count it, and what it looks like to me is 3.5. 1, 2, 3, and then this thread lines up with the 1 inch mark right there. So it should be 3.5. So what we'll do, we'll go down there to the Pacemaker and chuck this up, and we're just going to come in there with some kind of pointer to get in close, and we'll follow this and make sure that our pitch is 3.5. One of the things that I love about these old lathes, this one being the American Pacemaker, 20 by 192. Any of these old iron lathes, you know, American lathes, they have a really nice range of thread pitches that they'll cut, including fractionals. So they'll go down very, very coarse. A lot of your newer machines, your imported machines, I noticed they'll have a few fractional things that they can cut depending on their gears, but some of them I see only go down to 2. So these old machines, they got a nice range. This one goes all the way down to 1 thread per inch here. But see, you have your fractionals, and sometimes you run into that, such as the case today. So we're going to be looking at 3.5. I've got it set in this position right here, 9 to 3.5. A and E. So we got this one an A, this one an E, and then this is where you change from your lead screw to your feed rod, and we got it in threads right there. So let's set this sucker up. We'll get her chucked up here and indicated, and we'll see if we got us a 3.5 thread on this adapter. All right, let's get this thing indicated. That should be about close enough right there. That's about 1. There we go. We'll live with that. We're just gonna be following that thread. Yeah, it's actually it's really not truly on axis right there, but it's good enough for what we're doing. So we're going to use this grooving tool just as our thread cutting simulator to see if we follow the right pitch right here. So I got the machine set at 3.5, and on the dial, I'll go ahead and show you this too. On the thread dial here, since we're cutting a 3.5, what I'll use for a reference is the number 3 mark, and I'll just put me a little dot right there. And on a fractional, it's best just to go back to your same mark every time so you know you don't miss it. So I'll dot the 3 and I'll line up that one. Alright, here we go. We're just getting it close. And I'm going to wait for the dial to come around to my 3. Alright. Now I'm just going to drift the clutch here to make it go a little bit slower. Look at that. I can tell that I'm wrong on my measurement there. You see that tool? A little bit slower than the thread itself. So it's not 3.5. I must be rusty today. Whenever I'm looking at this, I'm seeing 1, 2, 3.5, but I think what we've actually counting here is 3. 1, 2, 3. I believe if this one was showing a little bit, like halfway, that would be 3.5. All right, I'm going to switch it to a 3 pitch on the quick change over here, and we'll try it again. All right, here we go. Let's see if our calculations are right on this. Tell you what, get it a little bit closer there. Again, I'm just drifting the clutch by hand. And it looks like that we're on it. I think that's what we got, is a 3. Nice. Let's do it again. I would say that's a 3 pitch. Here's a thread pitch gauge that we use at work. That's the Starrett number 155. I don't have one that goes this coarse, but you see we got a 3 pitch leaf on here. And even though this is a V thread and this is a square thread, you can still use it to verify it. You can see that it's fitting down in there. You got 2 of them that fall in perfectly. All right, so we learned something today. We got a 3 pitch there. So I told you guys that we're going to grind up a tool bit to cut this square thread. So that's what we're going to do. Now I've been holding on to the tool bit that I made originally, that I cut the first couple with. And that's that guy right there. That's the tool bit that I made. So that's 10 years old. That grind is 10 years old anyway. Made that back in 2006. That's out of a piece of Momax Cobalt 3/8 square. And it'll still work. That's still a perfect tool for this, but for video purposes and the channel here, I haven't done any tool bit grinding in a while, so we're gonna go ahead and make one, and I'll show you how I make it, get it made up. We'll make it look just like that, and we'll do our measurements on this thread here and see what we got to make it to. So let's go find us a tool bit. Let's see if we can find us a tool bit. Might be one in here. Too big. That's too big. It's 5/16. 1/2 inch. Some more 1/2 inch. Those look like quarters there. 3/16. These are all rectangular bits there. There's some Tang Tong G. These are pretty good too, but there's a Rex 95, Tang Tong. Ah, here we go. .3/8 Momax Cobalt. Last one out of the pack there. Got a few more hiding here. We'll put those back in our little secret stash before somebody finds out about them. So we're doing our measurements here to find out what we need to bore the shaft to, and then, you know, our tool bit dimensions. So I'll kind of run over what we got. Measuring the major diameter here with the 2 to 3 mics, we get 2 inches 74 thousandths. And I did this several times to make sure that I was measuring correctly. And I'm getting 73. I wrote down 2 inches 74. And then the thread depth, that is the thread from the major OD down to the bottom of the root there. And I used my depth mic, and I positioned it so that I could reach this very last thread. And just kind of holding it square and coming down, and we should be getting about 87. So 87 thousandths is our thread depth, times 2, that'd be 174. So you could take the 2 inches 74 and subtract it, you know, 0.174, and that'll bring you to 1.900 inches. So that would be the root diameter the very bottom of the thread there. But we need a little bit of clearance, and I'm not gonna use the 75% rule like we do for normal V-thread taps or V-threads. So I'm just kind of throwing a guess out there at 10 thousandths should give us enough clearance. We can go 15 thousandths if we need to, and then that's what we're going to bore it to. So with 10 thousandths clearance, we'll bore it to 1.910, and then from there we'll thread it on out to where this will screw in there. And then so we're grinding our tool not to fit here, because this tool is going to be leaving this thread that this tool that I'm sticking in there. So what we want to grind for is this thread right here. So I took some measurements several times, and I come to the conclusion that it's right around 160 thousandths, just depending on how you hold the calipers here. So about 160 thousandths. And this tool bit that I had ground before, we had it around 167 and a half is where it's at right now. 167. So we'll grind us another tool bit just like this, about 165 to 168 thousandths wide, and that should give me adequate clearance once I do this threading for this to screw in there. But what we're going to do is that we're going to have our compound set on 90 degrees, basically in line parallel with the ways of the machine, and I do it that way so that if you're in here threading and you need a little bit more clearance, you can run the tool either side that you want of the thread to cut it just a little bit wider, you know, a couple thousandths or so to widen out the thread. So I think that's where I'm at. Hopefully that all makes sense to you right there. And so it's time to get over there and make us another tool bit. All right, so we're over here at the Queen City grinder. This is a 12-inch diameter wheel, 2 inches wide. We got the coarse side here, we got the fine over there. We'll be using both of them. We'll come over to the other side once we want to finish out the tool. So just to kind of go over the tool real quick, this is the side that that will be going up in there first, you know, this side of the tool here. So we want to make sure that we grind clearance here so that it's only cutting on the edge there. You don't want it to rub on the side, so that's why we have to grind clearance. We'll have to grind some clearance across the front to make sure that we don't rub our bore. And then the same thing on this side of the tool too. We got to give it a little bit of clearance so that it doesn't rub. And that's about it right there. I'll try to keep it about as square as I can, maybe 1 or 2 degrees on the sides, so that it's not rubbing the entire side of the tool bit every time I go through there. And as far as the position of the tool bit, that matters to me too. See, on this one, the way that I ground this is that I've got cobalt on there, so that whenever I grab this tool, I know that I used a piece of cobalt, or I know what the material is. So I'm going to do it the same way that I did that one there, because we got to cut it off so it'll fit inside the part. Alright. Now I already adjusted these up just a little bit ago to get them, you want them as close to the wheel as you can without them rubbing. So we readjusted those. I dressed the wheels, and I've got this this other stick right here. I believe it's Narbide, and use those to go in there and kind of dress it, make sure they're flat too. So we'll go ahead and turn it on, and we'll give it another little rub. Just try to make sure that the face is nice and square. The wheels don't run perfectly true. They have a little bit of run out, but they get the job done. I don't know what they make that out of, but it's harder than rock. Alright, we're going to go ahead and get started. I need to go find me a little square. I don't have to make it quite as deep as I did before. That right there will probably work, but I'll go a little bit further back with it there. We're already pretty close right there. All right, I'm gonna go ahead and come over here on this side. I have my pads set on center line so that when I set the tool on there, when I come in there and grind, being above center line automatically puts relief onto the tool bit there. Once I get it really close to the top there, I try to be careful not to cut in there too far. Because I want to finish it over there on the fine wheel. Now, I got to switch it to this side so that I grind the clearance on this side of the tool bit. Got to be careful you don't take too much at once. Getting real close. I think that's close enough that we'll leave it and finish it over here on the fine side. Alright, so I'm going to go get a little machinist square so that I know that the tip of the tool is square with the tool bit itself. So here's a little tool square that I'm talking about, and you can use this as your gauge to make sure that the tip is square. Kind of like the threading tool, you know, so it's hard to see it here, but what I'd like to do is hold it up to the light and look through that gap and try to get it just as square as I can. And I'll do that over here on this side when we finish it. That looks perfect right there where it's at. The edge is nice and square. Now we'll relieve the bottom of it right there, like the other one here. So we'll have to grind a little bit on the bottom. I think one of the things I'm going to change on this tool, instead of having a flat edge, a neutral rake, I want to give it some back rake. So I'm going to lay it over here on the side like this. And I'm going to create a little bit of back rake. That'll help curl a chip a little bit easier when it's cutting. That looks pretty good. Alright, so we got about 10-12 thousandths to come off. We'll go ahead and I can see that I don't have it quite all the way to the top edge, so I'm going to go ahead and finish it out here. Nice sharp edge right there. easy to take too much, so you just got to be careful as you approach that width that you want. Not bad, just about there. I didn't get much that time, did I? There we go. Look at that. 166. So that's within that range that I was trying to hit right there. So we're gonna leave it just like that. All right, we're gonna have to, we'll go ahead and grind some relief on the bottom. And this you can do on either side that you want, really. Whatever wheel, I mean. It's just important to make sure you leave you enough area underneath the cutting edge to support the tool. You don't want to have no steep angle coming up to the edge, because that makes it weak and it'll chip off and break wear a lot easier. And you can kind of see on the how much I had on the original tool there. I'll take it up just a little bit more. And then for it work right there. Alright guys, I think we're about ready. I do want to break the corners slightly, just slightly, and then we'll go hone it to finish it. Just come up and touch it. I'm just going to do a little bit of honing on this thing. It really smooths out the edge there where it does the cutting and makes it really sharp. Yeah, it's looking nice there. Doing the nose of it is a little tricky. You definitely want that honed too, because that's where most of the cutting actions is taking place. You just got to hold it square. Make sure you're on the right angle. And just keep rubbing it until you get it home. And then this is a really fine hone there, so when I get done with, I'll just go over it and give it really just a polish. All right, I get through this honing, then we're gonna have to cut it off. This is the 1-inch boring bar that we're going to use. This has always been my favorite 1-inch bar. It's made out of tool steel. It's very strong, doesn't chatter like some of those other bars. So that's the one I like to use. You can get very close to a shoulder there. What I'm doing is I'm going to stick this in there, and I just want to see where I cut it off, where I want to cut it off there. I want to leave the cobalt lettering on there so I know what kind of tool bit it is. So I think I'm just going to go right between the Momax and the cobalt. Just right in there and cut her off. Just a little bit shorter than the other one there. Whenever you cut it off, keep the part that you're going to use as an actual tool clamped, and leave the part that you don't want hanging out, so that whenever this falls, if it falls and hits the ground or the floor, doesn't mess up your freshly ground tool bit. I got to where I like to wear hearing protection whenever I'm using grinders now. The older I get, I think I get a little bit smarter with my age. So, ear protection for me. That's the one we didn't want this one to hit the ground, remember? We'll go back over there and dress them corners there.